Assalamu alaikum. Welcome to my YouTube channel. Today I am going to talk about organic chemistry, and under organic chemistry I will explain what are isomers, addition polymerization and condensation polymerization. So let's start. First of all, I will explain about what are isomers. Isomers are the molecules which have same molecular formula but different structural formula. For instance, normal butane. I am going to give the example of butane. You know that butane is the fourth member of alkane. The first member is methane, then the second ethane, then propane, and then butane. Methane contains one carbon. Its formula is CH4. Then ethane contains 2 carbon, propane contains 3 carbon, and butane contains 4 carbon in the chain of hydrocarbon. So this is butane, and this is the structure of butane. It is containing 4 carbon. Carbon number 1, suppose I am writing the numbers, carbon 2, carbon 3, and carbon 4. And as we know that carbon is a tetravalent atom, means that it has 4 valence electrons and it is able to form 4 covalent bonds. So it will be represented, these 4 covalent bonds will be represented by 4 lines. So here, as I mentioned in the structure, that carbon is surrounded by 4 lines, 1, 2, 3, 4. Now the second carbon, once again it is containing 1, 2, 3, 4 lines. Third carbon 1, 2, 3, 4 and 1, 2, 3, 4. Remember that in organic chemistry, when we are talking about hydrocarbons, suppose each carbon has 4 lines representing 4 covalent bonds because carbon is a tetravalent atom. So here in the structure of butane, this is the straight chain. So 4 carbon, and now let's count hydrogen. 1, 2, 3, 4, 5, 6, 7, 8 and 9 and 10 hydrogen. So how many hydrogen this formula is containing? 10 hydrogen atoms. So I will write it, this butane is containing 4 carbon and 10 hydrogen. So its formula is C4H10, and this is the normal butane. So now come to another isomer of butane. This isomer is not the straight chain. This is the normal one which is containing the straight chain, but this is not the straight chain. It is in the form of a T shape like this. I am drawing its structure like this, T shape. Here 3 carbon are attached in a straight chain and the 4th carbon is attached on carbon number 2. I am writing like 1, or I will use different marker. 1, 2, 3. So 3 carbon are there in the straight chain and the 4th carbon is present in the middle with carbon number 2. But so now the structure is different. But if we count the number of carbon atoms, they are 4. 1, 2, 3, 4. And similarly, if we count the number of hydrogen atoms, they are 10. 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. It means its formula is also C4H10. Its molecular formula is also C4H10. So this is also butane with the formula C4H10, and this is also butane with the formula C4H10. But what is the difference? The difference is in their structure. So this is the concept of isomers. I repeat that isomers are the organic compounds They have the same molecular formula, like in this case C4H10, C4H10 for butane, but the different structural formula. This butane has straight chain, and this butane has branched chain. The structure is different. The structural formula is different of the same molecular formula. So these are considered two butanes, two isomers. One is named as normal butane and other is called as isobutane. Similarly, there are many other isomers of other organic compounds. Now let's talk about polymerization. So let me first introduce what is polymerization. Polymerization is when the different monomers are combined to form a polymer. Mono means single, mers means structures, single structure. When a single unit is there, it is called monomer. But when many monomers, when many single structures, small and simple structures, they are combined, so they form polymer. Poly means several, many. So polymerization is a process in which the different small monomers, the different small structural units or building blocks, they are combined to form a polymer, a large, long and a complex molecule, that is polymer. So this is called polymer, and the process is called polymerization. Now there are two types of polymerization. One is addition polymerization and the other is condensation polymerization. First, I will talk about addition polymerization. In addition polymerization, the monomers are of same type. All the monomers are of same type. For example, I'm taking the example of ethene. This is the structure of ethene. Why we call it ethene? Because it is containing two carbon and with double covalent bond. If it contains double covalent bond, it will be ethene. If it is containing single covalent bond, then it is ethane. But if it is a double covalent bond, then ethene. So it is ethene. It is one molecule of ethene. This is another molecule of ethene. This is another molecule of ethene. This is the fourth molecule of ethene. This is first molecule of ethene, second ethene, third ethene, fourth ethene, and fifth ethene, and sixth, and so many. Maybe they can be 1,000. Maybe they can be 10,000. So many, several monomers, but all of the same type. So let's see how we will join them. How will we connect them? We will connect them through breaking the double covalent bond. Suppose we will break down the double covalent bond of this ethene and we will connect it with this one. And we will break the double covalent bond of this ethene and we will connect this ethene with the next one. And we will break down the double covalent bond of this ethene and we will connect it with the next one and the next and the next. In this way, just by breaking down the double bond and connecting it with the next one, we form a polymer. So as this was ethene, so now the scientists name them polyethene. Polyethene. Suppose now this polyethene, its structure will be like this here. So when double covalent bond, they are broken, so they formed polyethene. So this is a polymer, and this type of polymerization is addition polymerization because the same type of monomers are used in addition polymerization. Or let's take another example. Let's suppose this is not ethene. So I am taking another example. Suppose I am using another monomer. So this monomer is suppose chloroethene. Chloroethene. This is one molecule of chloroethene. Why it is called chloroethene? Because on carbon number 1 here it is a functional group chlorine. So that's why it's called chloroethene. This is another chloroethene molecule. This is the third chloroethene molecule. This is the fourth chloroethene molecule, and fifth and sixth and seventh and eighth chloroethene, and so many. Maybe they are once again 12,000. Several. Now these are once again the same type of monomers. Now we will break down the double bond and we will convert it, we will connect it with the next one. We will break down this double bond and we will connect it with the next chloroethene. And we will break down this double bond and we will we will connect it with the next chloroethene and with the next chloroethene. And in this way, once again, another polymer will be formed. And as the building blocks were chloroethene, now this polymer is named polychloroethene. Polychloroethene. And as on every second carbon it is chlorine, so I will write here on every second carbon chlorine. For example, on one carbon, carbon number 1, chlorine, then hydrogen, then chlorine, then hydrogen, then chlorine, then hydrogen, and then once again chlorine, and then hydrogen, and then again chlorine, hydrogen, chlorine, hydrogen. Why? Why this structure is formed? Why this sequence is formed? Because this ethene is having chlorine on one carbon and on second carbon hydrogen, then chlorine, then hydrogen, then chlorine, then hydrogen. So the same sequence will be followed in polymer. This is another example of addition polymerization, and in this way polychloroethene molecule will be formed. So remember that in the Cambridge questions, you may be asked that how you will be given a structure of polymer and you will be asked to deduce that from which monomer it was formed. So from which monomer it was formed, by which you will focus on this structure. So you will say, okay, it looks like that the actual building block was chloroethene. So you will be able to deduce from the polymer, you should be able to deduce and infer that what monomer was there. Or sometimes the monomer is given and you will be asked to draw its polymer. So if the monomer is chloroethene, so you should be able to draw that how the polychloroethene will be formed. So these type of questions may come in the exams. Now the next is condensation polymerization. In contrary to addition polymerization, during condensation polymerization, two different monomers are used. In addition polymerization, same type of monomers were used, but in condensation polymerization, two different monomers are used. For example, one type of monomer in this case is dicarboxylic acid, OCOH. It is carboxylic acid because carboxylic acid is like this, COOH. It is a functional group and this is called carboxylic acid. And as this structure is containing carboxylic acid on its both ends, so this will be called dicarboxylic acid. And in the box it may be any molecule of a chain of hydrocarbons, but the common thing is that it is containing, or the main thing is that it is containing on one side carboxylic acid and on the second side carboxylic acid. So that's why it will be named dicarboxylic acid. And now this is diamine, dicarboxylic acid and diamine. Why it is diamine? Because on both sides there is a functional group NH2, which is amine group. So one dicarboxylic acid and one diamine is combined together. How? Let's say I am going to erase it. So from here I will erase OH, and from here I will erase H. So when we will join them together, so it will be joined like this: OCNH, OCNH, So a bond is formed. This bond is called peptide bond for this specific polymerization between the dicarboxylic acid, and it is in biology it is called peptide bond, and in chemistry it is called peptide link or amide link, right? So OCNH, the bond is same. So in this way nylon is formed. So nylon is a polymer which is formed through condensation polymerization by building the two different monomers together, by combining the two different monomers together. One monomer is dicarboxylic acid, the other is diamine. So in this way OCNH, 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 and in this way nylon is formed. So this complete polymer is called nylon, which is formed by condensation polymerization of dicarboxylic acid and diamine. And another important point of condensation polymerization is that when the two monomers are combined together, so they are condensed and a simple molecule, mostly water, is removed. So from here, as I am drawing it again, what was it? It was OCOH. And on the other side, what was this compound? It was NH2. It was here, the functional group was NH2. Here it was OCOH. But when it removed, so it will form, remember, it will form H2O. H2O, water. So from here, when we are going to join the two monomers, so water molecule will be removed. So during condensation polymerization, all the time, here water molecule will be removed. Here water molecule will be removed, and on each bond between each link one water molecule is removed, and the two different monomers, they keep combining together to form a polymer. Another example of condensation polymerization is the polymerization between dialcohol and dicarboxylic acid. Dialcohol is this one and dicarboxylic acid is this monomer. So two monomers are being used. One is dialcohol, because why it is dialcohol? Because on one side it is alcohol, OH group, on the other side it is alcohol group. And here why it is called dicarboxylic acid? Because on right side it is carboxylic acid and on the left side it is carboxylic acid. Now we are combining these two different monomers. So suppose when we will combine them, so from here OH and from here H will be removed. And when it will be removed, it will form, once again it will form a simple molecule, water. So it is condensed. The two monomers are condensed. That's why they are called, that this process is called condensation polymerization. So in this way, OCO bond is formed, and this OCO link is called ester link. And as this polymer is having many ester links, so what should we name it? Polyester, polyester, polyester. So once again, polyester is another polymer which is formed through condensation polymerization. So this is about polymerization. I repeat, there are two types of polymerization: addition polymerization and condensation polymerization. I hope you understood today's lecture. Thank you very much.